Hey everyone, let's continue on with our problem with this truss system. Okay, I've already determined that here at A I have 900 pounds and here at B I have 900 pounds. And now I want to start using the method of joints to discover what the forces are in each of these members. All right, so the method of joints, we go to each joint and we look at all of the forces acting at that joint. All right, so I'm going to do points A and C, joints A and C for starters, and then we'll continue on. So joint A, I've got a 900-pound force acting there. That's from that pin mechanism, right? That's pushing up with a force of 900 pounds. And then there's a tension in the member from A to C, and there's a tension in the member from A to E. And again, I'm assuming they're both under tension. They're not. One of them is going to be under compression, but let's assume they're both under tension. And again, I just alphabetical A to C. Even if it was CA, I would call it TAC. We'll get to that later. And then TAE here as well. All right, so there's my diagram. I know that there's some angle theta in here, right? So this is some angle theta, and that's going to be the same angle right there. And I know that the angle theta, let me say that the tangent of theta is equal to opposite. This is going to be 1/3 of the way up, so this is going to be 2 feet. Well, let me just do the whole thing. All the way to here, right? This is 6 feet. And then from here to here is 18 feet. And so the feet cancel, 6 over 18 is 1/3. So the tangent of theta is 1/3. So theta is the arctangent of 1/3, okay? And I don't really care what that number is. I mean, I do when I get my calculations done, but right now I don't care. Okay, so when I go to solve this problem then, we can do this. We're going to do force equations, right? Because now, here's the thing. When I do the method of joints, I'm always at a single point, and I'm looking at the forces acting on that point. And so there's never going to be moments because, unless there's moments at the point, but we're ignoring that for now. There aren't going to be any moments here because we're only looking at a single point, right? So there's some of the moments about A of all the forces acting at A is 0 because they're right there at the point of interest. All right, so what do I have here? Some of the forces in the Y. I'm going to do that first. I have 900 pounds up. And then TAE has no Y component, but TAC does. So plus TAC. And then that's the sine of theta. And that's equal to 0. And keep in mind, I know what theta is, right? So I've only got one unknown here, and that's TAC. Clearly TAC will be negative. And so AC, that member is in compression. All right, I know that's the case, but I'm not going to change anything at this point. All right, then the sum of the forces in the X. All right, the sum of the forces in the X. I have TAC cosine theta plus TAE equals 0. And keep in mind from the Y equation, I know what TAC is. So TAE here, I will now know. So I've got TAC and TAE. Those values are given. All right? So there's the first joint. Let's go to the next joint. And the next joint is at C. And this is actually the most interesting of the joints, I think. So what's happening here? So I've got these forces at C. So there's TCD, TAC, right? Again, I've assumed that they're all under tension. They're not, but I'm going to make that assumption anyway. And then TCE. But here's the thing. This is a really interesting spot. There are no other forces acting here. There are no other forces acting at that position. So let's just be a little different, and let's make my x-axis this way and my y-axis this way. And when I do that, when I look at the sum of the forces in the y, only TCE has a y component. TCD and TAC are both x only. Only TCE has a y component. And it doesn't matter that I call this x or y. this is going to be the case. TCE is the only force that's not acting in this line, which I happen to call X, but it doesn't matter. All these two forces, even if one's bigger than the other, they're acting along this line. Only TCE is not acting along this line. So there's only one force in this perpendicular direction, which I'm now calling Y just for this piece right here. In fact, let's make my life simple. Let's call it Y prime and X prime. So TCE is the only force acting in the Y prime direction. But if it's the only force and the sum of the forces in the Y prime direction are 0, then TCE must have no force acting on it. And this is what we call a zero force member. Okay? This is a zero force member. And so you always want to look for those because they're going to make your life a whole lot simpler. Right? When you have a zero force member, you can eliminate them. So technically, let's get rid of that angle sign. I can get rid of TCE entirely because it's not there. There's no force in that direction. Right? So I can eliminate that and I don't even need it. Now, do I need it when I'm building the truss? Probably. Because in this example, there's forces at A, D, H, J, and B. But in the real world, there's going to be forces all along this. If this is a roof truss, there's going to be the weight of the roof. And then if you get snow on the roof, not that we ever have snow in Wyoming, if you get snow on the roof, that's going to exert forces everywhere. In fact, in that scenario, technically this is no longer a truss, it's now a frame, but let's not go there. But there's going to be a force at C. There's going to be a downward force at C. And so it won't be a zero force member then. So you need that truss. You need that member, you need that member in the truss. As you design trusses, that's what you're going to learn, but let's keep things simple for now. All right, so I have a zero force member. There's going to be one here as well. Right? And that's going to be the end of that, right? Now, there's no other. So what about right here at D? This guy right there, is that a zero force member? I got forces to the right and up, forces to the left and down, if those are tensions. But then I also have this 400-pound force, right? So there is a force up and down here, and then DE is going to help take care of that. So that is not a zero force member there, at least not directly, right? It still could be, but I doubt it. All right, so there's zero force members. They're really cool. I really like them because they make our lives so much easier. Okay, so I found TAC and I have found TAE. And then this one, I don't really discover anything except that we have a zero force member, which is, actually I shouldn't say haven't discovered anything. That's a big deal to get that zero force member. All right, okay, let's pause for a second. We've only gotten A and C. Okay, now I'm going to have to do some more of these diagrams to figure out what else is going on. And we'll take a look at those in just a minute. All right, so hang tight. If you have any questions, leave them in the comments below. Thank you.